Hello students, and welcome back for 3.09 Honors. Again, this is for those who are taking the course for honors credit, and basically what we're going to do is take what we learned in 3.09 and expand on that a little bit. So be sure that you have completed that assignment before you attend this one. In this particular one, we're going to have the same standards that we did with 309 and the same objectives. Again, we are calculating the molar mass of a compound. And in this case, we're going to be focusing on hydrates, and we're going to be looking at empirical formulas again, a little different way of determining the empirical formula. All right, so again, make sure that you are comfortable with lessons 106, 204, dealing with unit conversions and molar conversions, and also 308 and 309. Again, naming compounds, doing molar mass of compounds, and then doing empirical and molecular formulas. All right, if you are still a little unsure about some of those topics, please make sure you go back and review those lessons. Attend an open tutoring if you need. Watch some more videos, but whatever you need, make sure you understand and are comfortable with those before you look at the 309 honors assignment. Alright, so with that said, let's go ahead and look at another way that we can figure out empirical formula. In the regular assignment, we are given the masses of the different elements involved. Well, in a actual laboratory, you're not just given the masses of the different elements involved. You have to go and figure out what those masses are before you can actually do the empirical formula. So the way you can do that is by basically taking your products and working backwards, if you will. If it's an organic compound, the process that we use is what's called combustion analysis. And basically what that is you take your materials, you combust them, which means they're burning, and back in earlier lessons, we talked about, the products of combustion are carbon dioxide and water. So basically, we can take the mass of the carbon dioxide and the mass of the water, and we can work backwards with some calculations and determine the mass of the elements involved. Because remember, an organic compound, we're talking about a hydrocarbon. We got carbon atoms and we got hydrogen atoms in some kind of combination. So we can work backwards and figure out the mass of carbon and the mass of hydrogen. And then of course once we have the mass, then we can easily figure out the empirical formula like we did before. So how would that work step by step? Well, first basically you would take a sample of the compound, measure its mass. Alright, then it is burned completely, so only thing that is left is CO2 and H2O. Alright, once we've got the mass of the CO2 and H2O, we then start our calculating. Now the way you would get the mass of those is you would use gas collection tubes, and of course just like anything else, whenever you are trying to find the mass of the substance, we always first measure the apparatus when it's empty, in this case the collection tube, and then we'll mass it afterwards once it's filled with the CO2 or the H2O, depending on which one that has been collected in that tube. And then of course we subtract those two masses to get the mass of the gas that we're looking for. Alright, now we can assume that all the carbon in the compound is now in the form of CO2. So we can use the stoichiometry again to work backwards and figure out the mass of carbon. We can then also do the same thing for the water. So we can assume that all the hydrogen from the compound ended up in the H2O. So again, we can work backwards to determine the mass of the hydrogen. Once we got those two masses, then we follow the same exact steps that we did in the regular assignment to determine the empirical formula. So if that sounds like a really long and fun process, it is. And we're going to walk through it step by step together so we can see how that works. So if you want, make sure you have some pen and paper handy, have a periodic table and calculator, and we'll walk through this together. Alright, so we have 1.50 grams of a compound that's made out of carbon and hydrogen. It goes through complete combustion and produces 4.12 grams of carbon dioxide and 3.37 grams of water. What is the empirical formula? Alright, so again, we have to use our stoichiometry and work backwards here. Alright, so we got 4.12 grams of CO2. And the first step is to convert this to moles. Right? That's always our first step, just like we've been doing. So we go to the periodic table and we look up our masses. Carbon is 12.011, and we add to that 2 of the oxygens, which are 15.999. And we have 44.01. So that would be on the bottom. 44.01 grams per 1 mole. Now step 2 is the ratio. Now if we look at the formula CO2, there is 1 mole of carbon. All right, remember we talked about this back in the regular assignment. So there's 1 carbon atom, so we can also say there's 1 mole of carbon for every 1 mole of CO2. Okay, so that's how we can easily make that conversion from the CO2 to the carbon. And again, we put the carbon on top with the carbon dioxide on bottom to cancel out the units. So then our final step to get to grams of carbon is multiplying it by the molar mass of carbon, which again we mentioned a moment ago, 12.011 for every mole of carbon. Okay, so going back through here now, right, the grams of CO2 canceled out with the grams of CO2. The moles of CO2 canceled out with the moles of CO2 here. And then the moles of carbon canceled out with the moles of carbon here. Alright, now just a little side note, stoichiometry is something we're going to cover in more detail in lesson 4.6 through 4.7. Okay, but for right now, again, just want you to see that the first step is we take the mass we're given divided by the molar mass of that substance. Okay, so that's like we just did in the regular assignment. Nothing new there. The ratio, we just simply count how many atoms are in the formula. And of course that's going to be 1 mole of that formula. So 1 mole of carbon for 1 mole of the whole formula. And then now to get it to grams, again we just multiply by the molar mass like we were doing back in 2.04 or 3.09. Okay? So we multiply by everything on top, divide by everything on the bottom. So we got 4.12 divided by the 44.01. The mole ratio is 1 to 1, so we can just skip that since it's not going to change the final answer. And we would end up with 1.12 grams of carbon. Alright, now we're going to have to do the same thing with the 3.37 grams of water. Alright, so again, the first step is the molar mass of the water. So we go to our periodic table. One hydrogen is 1.008 times 2, because it's H2O, plus the 15.99 from the oxygen, and you're going to end up with 18.01 grams per mole. Alright, now this mole ratio, when we look at the formula, H2O, we actually have 2 hydrogens for every 1 mole of water. Okay, so it's actually 2 moles of H over 1 mole of H2O. And then that final step, again, the molar mass of hydrogen is 1.008 grams per 1 mole. Okay, so 3.37 divided by 18.01 times 2 divided by 1. We actually have a ratio this time. Times 1.008. And we end up with 0.377 grams of hydrogen. Alright, so now we have the grams. Now we just simply need to convert that to moles. Okay, now we're back into just our normal empirical formula problem here. So 1.12 grams of carbon Right, and we need to convert that to moles, so we're actually kind of backtracking a little bit here. We're going to divide by that molar mass. Oop, 12.011, there we go. And we'll do the same with the hydrogen. Okay, and the conversion there, 1 mole. One 0.008 grams. Okay, so for the top one here, we've got 0.0932 moles. And then for the bottom one, we have 0.374. And again, that is moles. Okay. So of the two, the smaller number is the top one here, the 0.039. So that's the number we're going to divide both of them by. Okay, on the top, we of course will get 1. On the bottom, you get 4. So those whole numbers now become our subscripts. And again, that means we have C1H4. Now the last thing that we have to do is figure out the molar mass of a hydrate. Well, before we do that, we need to talk briefly about hydrates. All right, hydrate simply means water. Okay, that's why, if you exercise, you always hear people talk about, make sure you're hydrating, because it's water. A hydrate is a compound or a crystal that has water molecules within the structure. And it's always in a ratio. Okay, so you always have, one of the ionic compound with X number of water molecules. It's always an exact ratio between them. Now we can, of course, figure out those empirical formulas then based on those ratios, because they go back again to the number of moles. Now to get the molar mass of water, we do it just like we've done with the other things, okay, with the other compounds. The important thing though is when you see the formula, recognize that the dot does not mean multiplication. It simply is indicating that we have a ratio going on there. For an example, down here we have zinc phosphate, and you can see here's the formula. Zinc phosphate tetrahydrate is Zn3 parentheses PO42 and then dot 4H2O. That dot in math would mean multiply. In chemistry it does not mean multiply. In chemistry it just means we have a ratio of 1 zinc phosphate for every 4 water molecules. Okay, so again, how would we determine the molar mass of this? Well, we do it exactly like we were doing before. Just now we have that 4, so we have to distribute that through the H2O when we do our count for our atoms. Alright, so let's try this one. We got zinc. Alright, we're starting with a zinc. Okay, again going to our periodic table. The mass of zinc is 65.38. Okay, and there are 3 of those. Alright, so that's going to give us 196.14. Okay, phosphorus, we did that one in the regular lesson. That was 30.97. Okay, now that 2 outside the parentheses distributes through there. So we have P1 times the 2, so there's actually 2 of those. So we have 61.94. Okay, and now the oxygen, we've got 15.99. And again, that 4 the 2 distributes through, so it's 4 times 2, so we actually have 8 total oxygen. So we have 127.92. Alright, so now we just keep on continuing on here with the water this time. So we got hydrogen, and the mass of the hydrogen is 1.008. Okay, so again, that 4 distributes through, so we actually have 4 times 2. We actually have 8 hydrogen on that side. And that gives us 8.064. Alright, and then we got to do oxygen again, because we have some more here. So this time we got 15.99, and again the 4 distributes through the whole molecule, so it's 4 times 1, so we have 4 oxygens. Alright, and that gives us 63.96. Okay, so we take all of those and we add them together to get our total. All right, and we get a grand total of 458.024. And remember, the units are grams per mole. Okay, so the only difference here is that we have to remember when we're doing the hydrate portion that we have to multiply the entire H2O by that coefficient when we're doing the molar mass. Alright, so of course now we know how to do the molar mass, we can then determine empirical formulas of hydrates. Alright, and this is actually what you're going to be doing in the virtual lab once you get to the assignment for 309 honors. So how would we do that? Well, in the experiment, again, when you do this experiment, you'll see this. You're going to take a known mass of a hydrate. You're going to heat it until all the water is removed. Once you've removed all the water, the only thing left is the compound itself. That is called an anhydrous or dehydrate. Okay? Once you've got the mass of the dehydrate, then you can subtract it from the original hydrate mass to get the mass of the water. Alright? So, and then of course now, again, just like we've done with empirical formulas before, once you've got the masses you need, then it's just a matter of going through our steps to determine the empirical formula. Alright, so again, step by step, we're measuring the mass of the sample of hydrate. We heat it to remove the water. We measure the mass of the dehydrate, or the anhydrous compound. That's another phrase that you may hear. Alright. Dehydrate is also called anhydrous. In other words, it has no water. I'm just spelling it over here for you in case you ever come across it. Anhydrous. Alright, so then we subtract those two masses to get the mass of the water. And then again, we're just going to do some converting. Convert the mass of water to moles. Convert the mass of the dehydrate to moles. Okay, now the only difference, and you'll see this as we go through the practice problem together, is that this time once we get our ratio, the ratio here is actually going to be between compounds. Before, the ratio was the atoms. It told us how many atoms were in the formula. With the hydrates, we already know the atoms involved in the formula. The ratio is going to tell us the ratio between the anhydrous solid and the water molecules that are attached to it in the crystal. Alright, so let's try one of these. Alright, a 5-gram sample of a hydrate of barium chloride is heated and only 4.3 grams of the salt remain. What is the empirical formula? Okay, so we started with 5 grams of the hydrate and we're only left with 4.3 grams of the product. Alright, so to get the mass of the water, we're going to take those two and subtract them. Okay, that's our first step as far as calculations are concerned. We already did the experiment. So we have 0.7 grams of water. Okay? Now it's just like a regular empirical formula problem. We got to convert these masses to grams. Alright, so again, to do that we need molar mass. So we go to our periodic tables. Mass of hydrogen, again 1.008 times 2. Mass of oxygen, 15.99. And there's only one of those. So we add those numbers together. And again, we get a molar mass of 18.01 grams per mole. Alright, and that's going to give us 0.038887. And I always suggest when you're doing empirical formula problems to go ahead and carry it out a few extra digits at this point. That way you'll be sure to get the correct ratio when you go to do the division here in a moment. Okay, so that's the water. Now we need to do it for the barium chloride. Okay, so we were left with 4.3 grams of the barium chloride. And again, we need the molar mass. So we're going to go to our periodic table. Barium is 137.33, and there's only one of those. And then we're going to add to that the chlorine, which is 35.453, but there are two, so we got to double that. And again, to cancel out units, we have to divide. So it's going to be 208.236 grams per mole. All right, so 4.3 divided by 208.236. We get 0.02065. All right. Again, the next step in empirical formula is to divide both of those by the smallest number. So when we look at these, our smallest number is the bottom one, right? The 0.02. So we'll multiply the top by that number. And we'll multiply the bottom by that number. Okay, on the bottom, it gives us 1. My apologies, this should be BaCl2 right here. And then on the top, we get 1.9, which would just round off to 2, all right, because we want whole numbers. So now those become the coefficients, if you will. So we have BaCl2, right, because the coefficient there is a 1. We don't write the 1s. And then we have our dot, and then we have 2 waters, so we just have 2 H2O. And if we were naming this compound, it would be barium chloride dihydrate. Barium chloride dihydrate. All right, so same steps, just now our ratio at the end is going to be the coefficients, not the subscripts. All right, so that wraps us up for the honors assignment for 309. And again, just a quick checklist here, things that are coming up. You, of course, need to complete all the examples and practice problems in the honors lab or lesson tab if you have not already done so. If you still need some help, you can, of course, attend the open tutoring sessions that we have. Check your teacher's announcement page for the times for those and the links. There is a resource or a review sheet in the Resource Center you can use. And then you will have to do the virtual lab. Now, for the virtual lab, you, of course, will collect the data, and then basically you're going to write a lab report on your final information. So you're going to have title, materials, procedure, all of those things, your data, calculations, and then a discussion and conclusion at the end. If you need some help with that, we do offer completion sessions for the labs. So again, check your teacher's announcement page for the next available one for 309 honors. It is on a rotating schedule, so it does come up quite frequently. And then, of course, once you're finished, you'll be able to submit that lab report for grading. Once you have completed this assignment, then you'll be ready for the Module 3 discussion-based assessment. And, of course, you can contact your teacher to schedule that, and then you'll be finishing up and moving on to Module 4. I hope this was helpful, and we will talk with you soon.